Hey everyone, and welcome. Have you ever wondered what's really going on behind the scenes that keeps your favorite websites from just completely falling apart during a huge product launch or a big event? Well, today, we're going to peek behind the curtain and look at the invisible systems that are fighting a constant battle to keep the internet running for all of us. Let's get into it. Oh, you've been there. We've all been there, right? It's that moment of pure frustration. You're trying to snag tickets, log into your account, and then bam, you're locked out. But you know what? That's not just some random glitch. It's actually a sign that a hidden security guard is on the job.
This whole situation is what we call the digital stampede, and it's exactly what it sounds like. A massive, massive crowd trying to shove its way through a tiny digital door, all at the same time. The perfect example, trying to buy concert tickets online.
Okay, so picture this. We've got the SwiftyTix concert API. The moment tickets drop, you've got millions of real, actual fans just mashing that refresh button. But here's the thing. They're not alone. Not even close. They're up against thousands of automated bots that scalpers have built to just hoover up tickets at inhuman speeds. This tidal wave of requests can absolutely overwhelm and crash even the beefiest servers out there.
And when you break it down, the difference is pretty stark, isn't it? On one side, you've got a real fan. Their goal, just buy a couple of tickets. They're clicking at, human speed. But on the other side, you have a bot that's built to scalp thousands of tickets by just hammering the system with requests. The result is total chaos. Real fans get locked out, and the whole thing can just grind to a halt.
So how in the world do you manage this madness? How do you let the good fans in and keep the bad bots out? Well, you hire a bouncer. A digital bouncer, that is. Now, the technical name for this digital bouncer is rate limiting. It's a super important technique used to control how much traffic an application will even listen to within a set amount of time. Basically, it's the rule book that decides who gets in and how many times they're allowed to knock on the door. And this right here is the golden rule. It is all about finding that perfect balance. You've got to be strict enough to block the bad actors and stop the system from falling over, but you also have to be flexible enough that you don't accidentally kick out your real paying customers. It's a really delicate dance. So this digital bouncer of ours really has three core jobs. First up, ensure fairness. Give the real users a fighting chance. Second, maintain stability, which is just a fancy way of saying don't let the servers catch on fire. And third, and maybe most importantly, block abuse. Stop those bots and any other shady stuff in its tracks. So how does this actually play out in the real world? Well, the first strategy is kind of like having a bouncer at the main entrance of a club, just giving everyone a quick once-over. This is your broad first line of defense. In the tech world, this front door is what we call the edge, and it's handled by things called API gateways and load balancers. These are the very first things that any request to your service is going to hit, which makes them the absolute perfect place for a quick initial security check. And the logic here is super simple, and more importantly, incredibly fast. A request comes in, the system checks a really basic rule. Something like, hey, has this one IP address made more than 100 requests in the last minute? If the answer is yes, boom, access denied. Instantly. It's all about moving fast to shut down those obvious large-scale attacks before they can do any damage. But what about the traffic that does manage to get past that front door? Well, that's where a second, much smarter layer of security kicks in. Think of this one as the bouncer who's inside the club, checking a VIP list. See, once a request is past that initial check, the application itself has way more context. It knows who you are. Is this a brand new user on a free trial? Or is this a long-time paying subscriber? This lets the system have much more nuanced rules. For example, a pro user might get 1,000 requests an hour, while a free user only gets 100. And if we put these two strategies side by side, the differences become really clear. That check at the gateway, it's lightning fast, but it doesn't have much context. It pretty much only sees an IP address. It's perfect for stopping those huge automated attacks, like a DDoS attack. But the check inside the application, it's a bit slower, but it has way more context. It knows your user account, your subscription level, the whole shebang. And that is ideal for enforcing specific business rules and giving your best customers a better experience. Okay, so let's throw a modern curveball into the mix. In today's world, applications don't just live in one tidy little box. They don't have just one front door. They have a ton of them, scattered all across the planet. A lot of the big services you use every day have what's called a multi-cloud strategy. And what that means is parts of their app might be running on Amazon Web Services, while other parts are on Google Cloud, and maybe even some on Microsoft Azure. It gives them a lot of resilience, but man, it creates a pretty big security headache. And that is the billion-dollar question, isn't it? If you block a malicious bot that's trying to get in through your AWS entrance, what's stopping it from just waltzing over to your Google Cloud entrance and trying again? If your bouncers aren't talking to each other, you don't really have a security policy. You just have suggestions. So the answer is to have a unified central strategy. All of your individual bouncers at every single cloud entrance, they all need to be sharing information and reporting back to one central command center. That way, when a bot gets flagged and blocked at one door, that info is shared instantly, and that bot is blocked everywhere. It creates this consistent, impenetrable shield around the entire application, no matter where its pieces live. So why does any of this invisible plumbing matter to you? Well, because this digital bouncer, this rate limiter, it's the silent guardian of your entire online experience. You know, when a service promises you 3 nines of uptime, they mean they're available 99.9% of the time. To put that in perspective, that's less than 9 hours of downtime for the entire year. Hitting that kind of reliability is basically impossible without technologies like effective rate limiting. It's truly what keeps the lights on. So let's bring it all home. What are the key takeaways here? Well, rate limiting prevents crashes, keeping the services you love online even during those massive traffic spikes. It ensures fairness, giving you a real chance against the bots when you're trying to buy those concert tickets. It protects the whole system, acting as an absolutely crucial layer of security. And it even enables businesses to offer different tiers of service. It really is the unsung hero of the internet. And that kind of leaves us with a final thought to chew on. As our digital world gets more and more crowded with automated bots, these systems that verify who we are and manage access become more important than ever. So the next time you seamlessly log into a busy website without a hitch, take a second to thank the invisible bouncer who just waved you through. Thanks for joining us.